Welcome to the Network Plus Prepcast, your dedicated audio companion for mastering every objective on the CompTIA Network Plus certification exam. This series is produced by baremetalcyber.com. In episode 100 of the Network Plus Prepcast, we explore the concepts of static routing and administrative distance, two important topics that form the foundation of routing decisions in network environments. Static routing refers to the manual creation of routes on a router or Layer 3 switch. These routes define fixed paths for traffic to follow based on specific destinations, subnet masks, and next hop addresses. Unlike dynamic routing, which automatically adjusts to changes, static routing behaves predictably. Its simplicity and control make it especially useful in smaller or well-structured networks. Despite the popularity of dynamic routing protocols in modern networks, static routes remain relevant and practical. They are widely used in small office networks, lab environments, and situations where routes rarely change. They can also serve as backup paths for dynamic routing or as a tool for troubleshooting by isolating known traffic paths. Because they do not require negotiation between routers or the overhead of route advertisements, static routes offer a lightweight and efficient alternative when simplicity is a priority. The Network Plus exam frequently includes static routing questions, making it essential to understand both configuration and behavior. The structure of a static route includes several key components. First, the destination network is identified. This is the IP address range the router must reach. Second, a subnet mask or prefix defines the size of the destination network. Finally, the route must specify how to reach the destination, using either a next hop IP address or the local interface that leads to the destination. This information tells the router how to process packets destined for that specific network. Static routes require accurate data to function properly, as any mistake can lead to traffic being dropped or misrouted. Static routes are especially well suited for simple topologies where paths are predictable and unlikely to change. They are commonly used when connecting a small number of routers, each with only a few interfaces. If the network layout is static and there are no redundant paths, manually defining routes is faster and easier than configuring a routing protocol. Static routes are also useful in controlled environments, like labs or isolated networks, where traffic patterns are tightly regulated. Their predictability is a major advantage in scenarios where stability is more important than scalability. There are several benefits to using static routing. First, administrators have full control over routing behavior, allowing them to define specific paths that may not be chosen by a dynamic protocol. Second, because there is no need to send routing updates or maintain neighbor relationships, static routing introduces no protocol overhead. This reduces processing demands on devices and improves security by minimizing exposure to malicious route advertisement. Lastly, static routes do not require any additional configuration on neighboring routers, which simplifies the setup for small environments. However, static routing also presents certain drawbacks. One of the most significant is the lack of automatic failover. If a path becomes unavailable, the static route will still attempt to use it unless an alternate is manually configured. This can result in dropped traffic or inaccessible destinations. Additionally, any change in network topology must be reflected manually in the routing tables. As a network grows, maintaining static routes becomes time-consuming and error-prone. These limitations make static routing less practical in large dynamic networks, where paths are subject to frequent updates. To configure a static route, administrators use specific syntax based on the device's operating system. In most cases, the command includes the destination network, the subnet mask or prefix length, and either the next hop address or the exit interface. This tells the router exactly how to forward traffic for that network. Care must be taken to ensure that the next hop is reachable and that the interface is active. Misconfigurations can prevent communication entirely, so verifying the settings after entry is a crucial part of static route deployment. Once a static route is configured, it can be verified using the routing table. On most devices, this is displayed with a command such as show IP route. Static routes will appear with a specific code, usually S, and include details such as destination, mask, next hop, and outgoing interface. Administrators can also test reachability by using ping or tracer route commands. These tools help confirm that packets are being forwarded as expected and that the chosen path is functional. If the next hop is unreachable, the router will typically mark the route as inactive or remove it from the table. Floating static routes offer a way to introduce backup paths without interfering with primary routing protocols. These routes are configured with a higher administrative distance, meaning they are considered less trustworthy than dynamically learned routes. They remain in the routing table but are only used if the preferred path fails or is removed. This setup provides redundancy without requiring a dynamic routing protocol to manage failover. Understanding floating static routes is important for designing resilient networks and is frequently referenced in certification exam scenarios involving backup configurations. Administrative distance is a key concept that helps routers choose between multiple routing sources. It represents the trustworthiness of a route, with lower numbers being more trusted. For example, a directly connected route has an administrative distance of 0, while a static route has a value of 1 by default. Dynamic routing protocols have higher values such as 90 for EIGRP or 120 for RIP. When a router has multiple routes to the same destination, it selects the one with the lowest administrative distance, regardless of metric or path cost. Comparing administrative distances helps network engineers understand which routing source will be selected when overlap occurs. For instance, if a route to a destination is available through both a static route and a dynamic protocol, the static route will take precedence unless the dynamic route has a lower administrative distance manually configured. Directly connected routes always take priority due to their distance of 0. This hierarchy ensures predictable routing behavior and helps prevent routing loops or instability caused by conflicting information from multiple sources. For more cybersection content and books, please check out cyberauthor.me. Also, there are other podcasts on cybersecurity and more at baremetalcyber.com. In small network environments, static routing is often the preferred solution. These networks typically feature a limited number of routers and well-defined communication paths. For example, 2 or 3 branch offices connected with point-to-point links can be configured with static routes that require little to no ongoing maintenance. Once established, these routes provide reliable communication without the complexity of dynamic protocol tuning. In networks where stability is valued more than adaptability, static routing offers simplicity with minimal overhead and strong operational predictability. Static routes are also commonly used to define default routes. A static default route is a route that catches all traffic for destinations not explicitly listed in the routing table. This is especially helpful in edge devices that forward internet-bound traffic to an upstream provider. For instance, a router connected to an ISP may have a single static default route pointing to the ISP's gateway. This approach simplifies configuration while ensuring that unknown destinations are handled properly. On the exam, expect to see default routes used in basic internet connectivity questions. In larger or hybrid networks, static routes can still play an important role when used alongside dynamic routing protocols. For example, in policy routing scenarios where certain traffic must follow a specific path, regardless of dynamic updates, static routes provide a way to enforce behavior. They are also helpful as fallback options when a dynamic route fails. A floating static route with a higher administrative distance can take over. This integration allows administrators to combine the flexibility of dynamic routing with the control of manual configuration, enhancing resilience and control. While static routing has its advantages, it also increases the risk of configuration errors, particularly in large or complex environments. One of the most common mistakes is entering an incorrect next hop address. If the next hop is unreachable or invalid, the route will not function and traffic will be lost. Another issue is specifying the wrong subnet or prefix, which can result in traffic being forwarded to the wrong destination or rejected entirely. Overlapping routes can also create confusion, especially when multiple static entries attempt to reach the same destination with slightly different parameters. Scalability is another limitation of static routing. As a network grows, the number of required routes increases, and maintaining them becomes more difficult. Every change in the topology, such as adding a new subnet or changing a gateway, requires manual updates to each relevant device. This can quickly become unmanageable and error-prone, particularly in distributed environments. For this reason, static routing is generally reserved for smaller networks or specific cases within larger systems where the path is unlikely to change or must be precisely controlled. When troubleshooting static routes, several tools can be used to identify and resolve issues. Ping is often the first step, as it tests basic reachability to the next hop address or destination network. If ping fails, the administrator may use traceroute to identify where the packet path breaks. The router's own routing table can also be inspected using the appropriate show commands to confirm that the static route exists and is active. Additionally, checking interface status can reveal whether a downed port is preventing the route from working. Together, these tools help pinpoint and correct configuration or connectivity problems. Static routing frequently appears on the certification exam in questions that test your understanding of basic routing principles. You may be asked to interpret a static route configuration, compare administrative distances, or identify reasons why a static route isn't functioning. Expect scenarios that include both correct and incorrect configurations, requiring you to evaluate syntax, logic, and route priority. The simplicity of static routing makes it a preferred topic for entry-level routing questions, and a strong grasp of its mechanics will benefit you across multiple areas of the test. To summarize, static routing provides network administrators with a method of creating specific, unchanging traffic paths. It requires no dynamic protocol negotiation, reduces overhead, and gives full control over route selection. Static routes are ideal for small networks, direct links, and controlled routing scenarios. They are also valuable in hybrid environments where dynamic protocols need to be supplemented or overridden. While less scalable, static routing remains an essential tool, particularly when paired with an understanding of administrative distance and its role in route selection. To conclude, static routing involves the manual creation of path definitions based on destination networks, subnet masks, and next hop addresses. It plays a key role in default routing, policy enforcement, and failover scenarios. Administrative distance helps routers determine which routing source to trust when multiple paths exist. Static routes have an administrative distance of 1 by default, making them highly preferred unless overridden. Understanding when and how to apply static routes is a foundational skill in network design and an essential component of your success on the Network Plus certification exam. Thank you for listening to this episode of the Network Plus Prepcast, your trusted audio guide to the CompTIA Network Plus certification. This episode was produced by baremetalcyber.com. For more cybersecurity podcasts, books, and resources, visit baremetalcyber.com. Thanks for joining us for this episode of the Bare Metal Cybersecurity Plus podcast. For more episodes, tools, and study support, visit us at baremetalcyber.com. And before you take the test, make sure to check out the practice questions in the book Achieve CompTIA Security Plus SY0-701 Exam Success by Dr. Jason Edwards. They cover every domain and are a powerful way to lock in your knowledge.